Good afternoon, friends. Requesting everybody to take your seats for the next session. This is on a discussion on future demand of castings. Please take your seats, please, so that we can call the members on the dais. The session chairman for this session is Mr. R.K. Sabu, and I would request Mr. Sabu to come to the dais. Mrs. Aroskar, somebody can escort Mrs. Sabu to the dais. I would request some of the delegates who are sitting on the back rows, all the seats in the front are vacant. You could come forward, please. The lecture would be audible. Also, your questions could be taken up in a better fashion if you come forward. I'll just quickly go through a brief introduction of Mr. Sabu. Of course, Mr. Sabu needs no introduction. Everybody knows him in the ductile iron casting business. Mr. Sabu is the Executive Director of Cores India Limited. By profession, Mr. Sabu is a qualified chartered accountant and has more than 4 decades of experience in the industry. Mr. Sabu started his career with Hindustan Unilever, and since then, since 1987, he has been associated with Cores India Limited in various capacities. Mr. Sabu has hands-on experience of shop floor practices with modern management outlook and corporate work culture. I would now request Mr. Sabu to take over to request all the panel members to come to the dais. Thank you, Mr. Sabu.
I request Mr. Vikas Nadgir, DGM Strategic Sourcing, Mahindra and Mahendra, to come on dais. Now I request Mr. N. Santhanagopalan, SGM, Simpson and Company, to come on dais. Now I request Mr. Mahendra and Kamaraj, SQM QA, Simpson and Company Limited. Now I request Mr. Chandrakant Bande, Supply Quality Assurance Manager, Atlas Copco. Now I request Mr. Abhijit Jayant Advant, Deputy Manager Sourcing, FE Metals, Eaton.
Hello. Sorry to say, sir, he has got some problems, so he is not able to attend. So, and Mr. Praveen Katte also. You can tell about that. Okay.
Mr. Pankaj Bhosle, Commodity Manager, Eaton.
Yeah, both are from Advent, so they were not able to come because of this
and Mr. Praveen
COVID problems. You know, their company has not allowed them to come.
And Mr. Praveen Katte is also not able to come. Okay, so we start the session.
We can start the session, sir.
Yeah, thank you. Now I request Mr. Vikas Nadgir to please give your views.
Yeah, good afternoon. I am Vikas Nadgir, looking after strategic sourcing of castings for Mahindra and Mahendra. So, yeah, nothing more to say about Mahindra. We are one of the largest casting buyers in India, and we procure about 35,000 tons of castings every month. Today's topic, what I will be discussing is something different, which is lightweighting, which is a need of an hour. Today, in the morning session, we have seen many times all our team members, colleagues have spoke on lightweighting. So lightweighting plays a very important role, and that's why I would like to just emphasize on this subject. Everywhere people feel lightweight means it will be, this casting is of lightweight, where yield will be less, ye tutega, ye chalega nahi. That is what is the overall thinking what people feel. What we say is, yes, amount of material, what is excess flab or excess fab, whatever is there, that has to be removed. Muscles have to be strengthened to see that it take care of all the strength, whatever is required, without compromising on the strength, without compromising on the quality. We have to ensure that how you make on thin wall castings. So, why lightweight? Lightweight, see, one thing is government and consumers have started demanding on reducing the energy consumption. So lightweight definitely helps that. Second thing is lightweight. What helps is it reduces the fuel consumption, which in turn also helps us to reduce the carbon footprint, which is a need. Cost, yeah, in the morning session we also heard a lot about cost. So lightweight components, overall if you see, lightweight component increases the production efficiency and also it helps us to reduce the cost. Lightweight also helps us to have a better component performance. Ability to recycle. We can break, tear and then again use it in scrap easily. So recycling also is one of the things which can be. Last one thing is reduced weight also can help the vehicles for advanced emission control and safety devices without increasing overall weight of the vehicle. So this is one of the things which can be done on that. So with above environmental and economic benefits, now lightweight is or should be a focus area with all of you sitting here and should see that we put all our efforts on research and development to do lightweight castings. Lightweight ferrous castings, yeah, it's possible, but we as a mindset we say it's a tough thing. Change is difficult for everyone, so more the change is required, you will feel a lot of resistance. Whenever we float the RFQs and say that we want a thin wall casting of X mm, then within another 2 days after study we get a reply, isko thoda either aap thickness badhao. Either manufacturing wise, yes, we are ready to do that, but not as an additional weight, whatever is there, where genuine requirement is there, we consider it. But we see queries coming in saying that itna patla nahi chalega, it will not be manufactured. The similar type of castings as a challenge are produced worldwide. But here we see a lot of reluctance for changing the thickness. So my humble request is, yeah, it's a challenge. Let us accept this, where global demand for thin wall castings are very high. And it's an opportunity for all. Right now, there is a trend where many people are feeling that cast iron is being substituted by aluminium in automotive applications. Why? Because of such things, what I said earlier, a lot of reluctance, and aluminium is easily doable. So people feel, let us change over to aluminium. However, on the analysis, optimization analysis, whatever has been done, it demonstrates that cast iron is far, far superior than aluminium. And in many type of applications, cast iron plays an important role. So if we are at par, if you look at the cost of aluminium and when you compare it with castings, yes, it's really a good thing that cast iron is comparatively cheaper than aluminium. And if you utilize this, this will be a good opportunity for all. What I mentioned earlier also, the main reason for substitution of cast iron seems to be inability or lack of interest. Jitna mota, utna zyada weight, utna zyada paisa, utna zyada ease to manufacturing. So I'll be very transparent and blunt to tell that. But this is what I have seen many times. So whenever any drawing goes with about 5 mm thickness, they will say, why not 6 mm? It's a risk. So let us change that mindset. This is the last point here. Recent research work has revealed that lightweight cast iron parts can be produced using regular charge material and commercial alloys for liquid treatment. It is also found that mechanical properties of thin wall ductile iron are superior than aluminium. So we can, it's a study which has been done. I have just picked up from some paper, but it is proven that ferrous casting is better than aluminum in some of the content. Another one good property, that is strength, stiffness, high temperature performance, damping capacity is far better. Reducing of thickness of cast iron on thin walling by adding relevant alloys has a very good potential in the industry. We have very good opportunities. People are eager to buy thin wall castings, and if you prove it and if it is a success story, definitely a lot of global opportunities are there sitting at our end. Now, looking at the overall aluminum trend, whatever I have seen or from the last so many years put together, when we have, as we are looking after both tractors and automobiles, the changes what I have seen in recent thing is, if you look at the old castings or old tractors, whatever were produced about 20 years back, we had about 90% of ferrous castings and 10% of SGIN. In the present tractors, whatever we produce, it's about 60% is ferrous, 30% is SGIN, and about 10% now aluminum has started penetrating. But new generation tractors, whatever we are looking after, or which will be coming in coming years, which will be used for specific applications, there if you see, the situation is reversed. Some tractors, what we have produced now and which will be coming in the market in future, has about 50% of aluminum, 20% of SGIN, and only 30% of grey iron. So it's a worrying thing for all of us. So we have to have focus on this and try to see that how it can be reversed by producing thin wall casting. Similar thing is in the automobile side. In automobile, yes, automobile need is there, that fuel efficiency plays a vital role, weight of the vehicle plays a vital role, and also this improves the fuel efficiency, and there's a demand from government and even the demand from customers that it should be lightweight and has, which gives us a very good driving comfort also. So this is the change what has happened in coming in this, the trend whatever is there is aluminum going in automobiles. But worrying factor is in tractors, that tractors consume maximum number of ferrous castings. Its highest consumer of ferrous casting is for tractors. And if that change happens, then that is something which is very worrying thing. Yeah, success stories, yes, when we say lightweight and thin wall castings, if you see at both the tractors, whatever have been produced, substantial weight has been reduced in these castings in last 3 years, without compromising on the quality, without compromising on the functions. After doing all the testing, validation, everything, we have seen that the weight has been reduced, but reliability and performance has not changed. So it's possible. We can do it, and it has to be done. It's easily doable, but only thing is our mindset has to be changed. Last but not the least, let's all of us work together for lightweighting of ferrous castings, which will help the industry to grow in multifolds. So request all to please focus in this area. Thanks a lot.
Yeah, I request Mr. Sabu to give the memento to Mr. Vikas Nadgir.
Good afternoon. Thanks for the opportunity for presenting Simpson's requirements here. I am representing Simpson, which is 175-year-old organization, or more than 175-year-old organization. We are the members of Amalgamations Group. We have got a rich history. Before I move on to my main presentation, I would like to congratulate the IFEX team which has done a commendable job in organizing this event. It is not a small event, it is a very big event, and it is not easy to organize such an event with great amount of digitization. The communication is flawless. The arrangements are extremely good. So I take this opportunity to congratulate the IFEX team, the entire team who have worked tirelessly in making this event successful. Simpson is one of the leading diesel engine manufacturers in India. And more than 80% of our engine goes for farm sector and balance goes for industrial and genset applications. With coming to our main presentation, we are in the midst of our exciting times India is going through. There could be challenges, but it is up to us to overcome the challenges and move ahead. In the morning, there were a lot of data that were shown, and you could also find that India is also in an advantageous position in various factors. We are number 3 in the GDP, thanks to the policies of government and the good infrastructure that is being built across India. However, it is work in progress. I will be touching on 2 requirements here, a kind of business overview, where the casting industries are, where the requirements are as on today. There are many fears being expressed by many people. The redundancy of casting industry, which is not so. So I would like to give a kind of confidence to the members here, what is going to be a kind of future for all of us. Having said that, it is also equally important for this industry to provide some good castings. Again, in the morning meeting, we have seen a lot of discussions that have taken place with respect to the quality. So we would also like to impress upon the requirements from an engine manufacturer, engine perspective. What is the requirement? How the industry is looking at currently? What we were 20 years back and what we are today, it is not one and the same. The requirements are changing every day, and this is the reality we need to accept. And the casting industry is also not exemption to this. As I said, I have 2 agendas. One, I will be touching on the business overview, and the development process and the ongoing process quality requirements will be dealt by my colleague, Mr. Mahendra. If you look at the past 5 years trend of casting requirements, Simpson buys close to 55,000 to 60,000 tons of castings every year. There were dips, but it is part and parcel of the market economy. We have 20% market share in tractor segment. As I said, we predominantly our engines are going for tractor application. What are all the demand, the driving factors for us in the coming 5 years, which are also one of the expectations from the casting industry? If you work on the Potter's 5 force principles, there are global market factors, domestic market factors, bargaining power of buyers, and the bargaining power of suppliers. Today, I would like to touch upon two things. What are all the global market factors and what are all the domestic market factors? If you look at the global market, there is a huge food and agri-export opportunity currently. You could have read in the newspapers that India is going to export a huge amount of agri requirements. Morning also, one of the speakers touched upon this topic. The Russia-Ukraine conflict and geopolitical development gives a huge opportunity for India. This was also discussed in the morning meeting. The emerging economic and political situation in Asia, like Sri Lanka or Pakistan, you could also see certain developments. The Europe foundry offloading to India, this was also discussed in the morning meeting. And if you could have witnessed, last year, the tractors export was at 128,000 compared to the previous year requirement or the export numbers of 84,000. So there was a 45% jump in the export market requirement. In 2021, I think it was the highest ever tractor produced in India, and we made close to 950,000 tractors, out of which 120,000 plus have been exported. Let us look at the domestic market factors. This was also touched upon in the morning meeting. Zero defect. Touch me not product and quality and service quality expectations. This is the expectations as of now. Premium, attractive quality characteristics, touch and feel good factors. This was also expressed in the morning meeting that touch factors, aesthetic is being demanded. Recently, I have come across the one incident where one of the person, a youth, has bought a tractor and kept in his house just to showcase his affinity towards the tractor. This is the kind of situation that we are in today. The youths are entirely different what were earlier and what we are today. So the youth customer base with high aspirations, this is one of the factors that need to be reckoned in. We have also touched upon in the morning electronic, remote control, drone, driverless, IoT, machine learning. These are all the topics that we are on today. Alternative fuel, CNG, hydrogen, electric are also being discussed. The tractors erstwhile were used only for farm segment, but it is not today. It is used for variety of applications. So the demand for the tractors are on the increasing trend. The ethanol and fuel encouragement by government to benefit sugarcane farmers, this is also one of the influencing factors for the segment to grow. The monsoon that is good in India for the last 7 years or so. It is a good thing that is happening, and government infra spending has also increased multifolds in the last few years. This was also shown by the speakers that the infrastructure building has increased tremendously. So in the morning, there were several questions about EV. Specifically, the foundry industries are talking about EV. Whenever I visit any of the suppliers, this is one standard question that I always get. EV, whether we should invest or not. So I am touching upon this. The challenges, concerns in product safety, you could also hear that there were a lot of safety issues. Fire has happened in the two-wheeler. Close to 40 two-wheelers have caught fire. In the recent newspaper, you could have read this. The environment, again, this was also touched upon by the morning speaker. It creates more pollution than even casting because of the the battery usage. It is also a concern in rural infrastructure. Recharging stations are not adequate at the present point of time. So I am talking EV from the perspective of farm segment. Tractors' working environment are completely different from the automotive. The high cost of product ownership and service. In the automotive, the owner of the vehicle is different. The owner and the driver will be the same. But it is not so in the tractor. The product usage, dealer and technician, and customer education are completely different. Again, this was also touched upon in the morning. As aptly he has put in, the EV will be an intermediary. It will not be a final one. We are getting matured. In our view, what will happen is, over a period of time, we may switch over to hydrogen for a better environment concern. It will get settled only in hydrogen or CNG in the short term. So what we look at is in the medium term for next 5 to 10 years, electric tractors are not going to be the reality, though it may come in few numbers, but not in many numbers. Let us touch upon the challenges and outlook for the immediate terms. The common rail engines are going to be there in the next couple of years, even for the lower horsepower segment. Currently, the norms even that was applicable for greater than 50 HP has been postponed by 6 months. From 24-25, even the current breadwinner or bread and butter of every OEM is between 30 to 50 HP. That is going to get changed over to the TREM 5 norms. So this requires a stringent dimensional accuracy. It is not like the current engines. This requires improved cleanliness of castings. The millipore value is very important. The particle count are very important. The cleanliness. User and owners are different, so the quality perception will change. Cost of product ownership and service are going to be different. Serviceability and product familiarization. So to give a perspective, the current engine price versus the CRDA engine price, there could be a difference of a minimum of 50,000 rupees to 1 lakh. There will be a difference only in the engine price alone. Then there are other things with respect to the OEMs. They will add a few more things. So this customer will not look at that as a CRDA engine. For him, he doesn't know about the emission norms, but he has to shell out more than what he is currently shelling out. So it is definitely going to be a challenge for all of us in the industry. The serviceability and product familiarization are entirely different. At least for the automotive, it was from BS3 to BS4 to BS6. But as far as this tractor industry is concerned, it is from TREM 3A, which is a legacy, to CRDA is a big shift in the requirements. Cost to value ratio is same for end user, except emission compliance. This is what I was informing you. And there are also likely potential shift from very low HP to medium HP, like 40 to 50 HP tractor, because of the cost, minimal cost difference. So we have a strong mitigation plan to embrace these challenges in the next couple of years. So what is the business outlook? For the current financial year 22-23, we forecast a volume of 5% increase over the last year. We have produced 174,000 engines in 21-22, which we expect in 24-25 crossing 2 lakh engines. And this is a very, very pessimistic target, what I have shown here. The casting demand in 21-22, we have procured close to 65,000 tons. And in 24-25 or 25-26, it is going to increase to 80,000 tons, which is almost a CAGR of around 5 to 7%. As far as our capacity of assembly is concerned, there is no issue. We have got abundant capacity to make. Whatever the casting capacity today we have got, it is close to 180,000 engines. But going forward, to meet the increasing demand, there will be a shortfall to the extent of 15,000 tons, which need to be added in the next couple of years. It can be either from the current suppliers or from the new suppliers. So the gross root level issues and trend in the current industry or the specific to casting industry, the cash and workflow capital management is very, very challenging. We are aware of it. Long-term investment at the cost of working capital, it is also happening in few organizations. Vendors are expected to manage inventories on behalf of the customer, thereby the working capital is locked up. Increase credit period to customers, and the interest rate what they are getting from the bank is quite high. And specifically the tractor industry is a seasonal industry where the first 6 months of the financial year is very high and the next financial year, next part of the year is relatively low. And the casting industry have to accommodate these challenges and support us. With respect to the manpower planning and retention, the long-term employee retention, there are challenges in the casting industry, both for the production and the design. Morning again, the speaker has touched upon the very low penetration of digitization in foundry specifically. This demands for workforce with data and digital skill set. There are industries where they are coordinating with some institutions with role-ready manpower. Thereby, they can be inducted easily into the organization. So here, the training and the development is very key for the industry. Morning, again, we have talked much about the raw material concern, the pig iron and scrap cost. The government policy on mining and vehicle scrappage is also having an impact as of now. We also depend on foreign sources for some special sands and the other additives and inoculants which we talked about in the morning. Industry and technological, e-vehicles we have already touched upon. The 3D printing manufacturing also helps to reduce the development time and cost. So here, I would like to just summarize. The casting industry must be ready with a short lead time plus right first time and consistency in quality. These are all the key in the current casting industry to support the customers like us. So now I request Mr. Mahendra to take through the quality requirements.
Good afternoon. And I thank my company and Mr. R.K. Sabu and IFEX President and coordinating members for this opportunity. Looking at the time factor, I would like to compress as quickly as possible. Morning we discussed about the situation regarding the market, how it is and how it will be in the next 3 to 5 years. In the next 5 to 10 slides, I am going to discuss about the development process. What is the process we can adopt to embrace these challenges, to capitalize on these opportunities which are prevailing. The first thing I would like to touch upon the right first time. In an ideal situation, we have the timely flow of money, resources, and output. We get an inquiry, we review the facilities, feasibility, techno-commercial offer, everything is okay. We get into design and development. Development timelines are adhered. First off sample and PPAP are okay. And in mass production, we monitor the serial schedule versus supply, rework and rejection levels. This is how a normal day looks like. We listen from the morning that there is going to be challenges. What we have overlooked for some time in the industry, we have to look at it. These are all these factors. During the design and development, there is inordinate delays. Okay, inordinate delays may be due to factors from customer side and also factors from the foundry side. Last minute changes in the product design, machine selection, changes in the tooling, tool design, all those things. As a result of this, what happens, the originally developed tool is undergoing a rework of tool. As a result of that, it is losing the original efficiency it is designed for. Once the design phase is not handled properly, subsequently we have issues with respect to mass production, rejection levels are going up, schedule versus supply is not honored, rework and salvage of the castings, WIP, waiting for decision, and it is a fatigueful and stressful job for both for the foundry as well as for the customer. So these things I call it as the pull-down factors. So with these pull-down factors in place, the real situation is the movement of dates. So whatever commitments made to the customer is not honored timely, and we lose the time, money, and resources in this process. So if we want to have a right process, if we want to have a right result, we need to have the right process. That is what I am going to touch upon in the next slide. This is a generic process in any company you can look at. It starts with the supplier selection, onboarding, quality planning, then PPAP, then supplier performance monitoring in the long run. When it comes to casting development process, it is a subset of the development process, product design, process design and development, process proving, and then PPAP. So in the next few slides, I will be touching upon what are all the inputs we will be giving and what process steps we will be following and what is the output expected out of these individual phases. The first one is the product design. Here the inputs are the machine 3D model and 2D drawing from Simpson or any customer per se. Then flow box data, envelope model, current issues and lessons learned, whatever from our experience, we'll share it with you. Then the critical steps. If it is an existing product, we will insist for the 2D, 3D and actual sample comparison. This is to avoid the later part of changes. As I mentioned in the earlier, there are a lot of last minute changes that are coming up because of this differences we find in the legacy product. Then point number B, mating parts superimpose. After we make the complete castings, we come up with some issues like it is fouling with some crankshaft, it is not entering, something like that. So we wanted to take care of these factors during the product design phase. Then optimization of wall thickness and weight. My predecessor have mentioned about it. Water volumes, cleanliness friendly castings. As we go for CRDI, cleanliness is paramount. Output. In this phase, we get, what is the final output we get? We get a 3D model, which is for product 3D model, which is approved by Simpson R&D. The expected lead time is around 3 to 6 weeks. We have to engage the right talents from both from customer side as well as from the foundry side. And we need to ensure that there are frequent and top level reviews are happening. The next step is the process design and development, where we have the input from the previous stage, that is casting 3D model, duly approved by Simpson R&D. Then these process steps are familiar to you. We design we design the planning, we design the layout planning, core box design, simulation. As output of that, we get the productivity daily targeted pour rate. Okay. So later part of time, we ensure that the capacity whatever allocated for a particular item is met. The second item is the simulation. As a result of the simulation, do we need any more changes? Then APQP timing plan, target yield. We need to target the yield of around minimum 70%. The best in class is around 80%. So here the lead time is 6 to 8 weeks. The close coordination between the functions are very important. The CFT focus is very important. That will ensure that there are points that are in anticipation. We are taking the feedback not in a reactive mode. Next is the pattern making. Here the input is the complete methoding and the core box and pattern models. Here we make a make or buy decision, master timing plan, die cutting, and first sample making. The output of this phase is pattern set assembly is ready, and we made the first casting and the 3D scanning of the patterns, core boxes, and the first samples. So the lead time expected is again 6 to 8 weeks time. Now, once the development is over, the next critical stage where you get customer interaction is first off sample. We verify all the material factors, dimensional factors, and surface finish factors. So here the key point I would like to touch upon is the timely completion of the tasks and single point document and record reference. We should not store material report only in, it talks about the project management basically, where we need to have all the data organized in a single point. Similarly for machining, it's a vast area. Still I have compressed this requirement into two half. One is the during development, what are all the things that we have to ensure? We need to ensure that there is a proper proto control plan, special cutting tools, SPMs, cleanliness measuring equipments, special inspection equipments need to be planned in advance. It should not come as a surprise because it's all add to the cost of the total project. During FOS and PPAP, we need to ensure that the key major characteristics or capability requirements are met. Morning, we have discussed about the rolled throughput yield, starting from the casting stage till the machining final inspection stage. PDI, training of the manpower, cycle time measurement, and runner trade certification, perishable tool control. So these are all things we need to ensure during this PPAP stage. Now, I would like to give some inputs regarding the disciplines of execution. Since the first portion is talking majorly on the project management. The first discipline is the focus on the wildly important thing. Second thing is the act on the lead measures. 20% of our actions are leading to the 80% of the results. And the third discipline is the keep a compelling scoreboard, monitor it. The fourth one is the accountability. So for every action, every activity, every decision, there should be an accountability both from customer side as well as on the foundry side. So for further reading, I suggest the 4 disciplines of execution book. The cover page is given here. Now, getting into the serial production. The serial production expectations, I have given some success factors here. The first thing is the digital daily management. So the customer base for a foundry is very, very lengthy. The supplier base also is a very lengthy one, and the customer base also is a lengthy one. To manage the date, and the process also is a lengthy process. So to manage all these three factors, the process, the customer, the supply chain, and the customer chain. If you have to manage it better, the only better way to get into the digital daily management system. The second thing is the knowledge and attitude and skill of the workforce. So organizations have to find a way to manage this knowledge, skill, and attitude of the workforce in a day-to-day. Then these are all the 4 pillars I would like to stress upon. The first one is customer centricity and sensitivity. The second one is the effective audit program. The third one is the quality cost monitoring. The fourth one is the regular review mechanism with the customers. So with these 4 pillars, we can ensure that the quality whatever we are making is best in class. So now in the next few slides, we are going to discuss upon the serial production success factors one by one. These are all the 4 success factors. The first one is the customer centricity and sensitivity. You look at the customer chain, tier 1, the way we have, the morning we saw the supply chain, tier 1, tier 2, tier 3. Similarly, we have customer chain, which is tier 1 to tier 4, it is there. The real user is the tier 4, tier 4 is the end customer. Okay, what is the challenge we have is the time. During development also I talked about time, and now also even in serial production also I am talking about time. Timely response, it is very, very important. As we go on to tier 1, tier 2, tier 3, tier 4 customer base, as the casting reaches these customer base, the effort and cost required to fix and improve at any defect, maybe a visual defect or a leakage or any performance issues, it is taking enormous amount of cost and time. So it requires sometimes campaign, callback, service bulletin. These are all the challenges the OEMs are facing. We are facing. I mean, the engine manufacturer, tier 1 engine manufacturers are facing from our customers. So the factors, the success factors is very clear. The first thing is the containment action within 24 hours, interim improvement action within 7 days, permanent action within 30 days. So this is the expectation. The second thing is, second success factor is effective audit program. Our audit programs are always, if you go to any quality management audit, internal audit of any foundry, you will find most of the things are, good, very good. The audit, no NC points like that. But we have pitfalls there. First thing is the customer QCD feedbacks are not taken into a consideration for the internal audit. When you are conducting an audit, you should start the customer requirement have been fulfilled or not. You should start the audit there first. The second is the poor qualification and the lower levels of the auditors. So when the auditor comes back and say that there is a concern, there is a problem, there is a non-conformity, and very few are responding positively to that, or it is totally ignored. The third one is the open issues not escalated in the right forum. So there are issues identified, and it is kept pending for a long time. So we need to define a escalation matrix and discuss and close it then and there. The success factor here is the layered audit, both bottom up and top down, because the people working on the shop floor knows better than the people sitting on the drawing board and making the design, right? So we should ensure that the top down and bottom up, both type of approaches are ensured, and the customer should be at the center of the audit program. The third factor is the cost of quality. I would like to give a small example here. A water jacket core running with a vertical core shooter having 30% core rejections and 100% rework. Okay, this is a real case I would like to tell you. I don't want to mention the name of the casting and things like that. And because of this, we have a machining rejections of around 8%. So cost of the horizontal core box is around 5 lakhs. When we accurately calculate the cost, labor cost of rework, cost of casting and machining, the machining and casting cost, loss of machine time in Indian rupees. So when we calculate all these things, definitely it is less than 5 lakh rupees going forward, right? So what is the success factor here is the strong and sensible quality cost accounting is needed. This is required both to convince the customer as well as the business itself. So a sensible cost of poor quality accounting is required. Then the fourth one is the regular quality review mechanism with the customer. We should ensure that the customer is happy at the end of the day. Okay? Or do I need some support from the customer to make him comfortable? Is there any open issues I'm maintaining? What is the escalation matrix at customer end? What is the escalation matrix at foundry side? And is the review frequency is adequate? And what is the time, cost, and scope factors for improvement action? So all these things have to be discussed in detail and then frozen with the customers during the regular quality reviews. So reviews are for the mutual benefit. They are not one way. Accountability and timeliness matters. So with all these things in place, what kind of manufacturing line we want, what kind of manufacturing value we want is foundry rejection. The first layer you see is a best case. The foundry rejections less than 2%, machining end of line rejection less than 2%, assembly end of line rejection 100 ppm, OE plant and field OE failure, early failures 0. So these are all this is the benchmark level. Of course, currently we are not at this level. Many businesses are not viable because of we are all in this. Many of the companies are operating in the third layer, where the rejections are more than 6%, foundry and end of line rejections, machining rejections are more than 6%. So because of this, some business viability itself is a question mark now. So end of the day, what I wanted to tell to the team is that aim to set a new operating benchmark. Okay, take the leverage of this Industry 4.0 and the digital solutions that are available in the market. With that, I'd like to conclude this session. I'd like to thank everyone and thank you.
Thank you very much, Mr. Kamaraj and Mr. Santhanagopalan. I request our session chairman, Mr. R.K. Sabu, to honor them with the memento.
Down to the king.
Thank you very much, Mr. Sabu.
Now I request Mr. Chandrakant Bande to share his thoughts and presentation.
Mr. Chandrakant Bande is SQA manager from Atlas Copco.
Good afternoon all. First of all, thank you for giving me opportunity to present my company's organizations and our casting requirement. Also today's session in charge, Mr. Sabu sir, and coordinating managing committee, Syamal ma'am, Purohit sir. Thank you all. I'm going to share quick. First of all, I will start with my introduction. My name is Chandrakant Bande. I'm working at Atlas Copco India Limited as a supplier quality assurance manager. By qualification, I'm a BE Mechanical, MBA in operations. I started my career working in foundry. For first 12 years, I worked in foundries, Kirloskar Group, 4 years. Then Chorus India Limited, Pepco Foundry, 2 years. Then DGP Hinode, 7 years. From last 15 years, I'm working in Atlas Copco India Limited as a supplier quality assurance manager. And during working in last more than 25 years, the key competence, skills, what I achieved, it's related to casting, development, process parameter optimizations, design optimizations. I used to be a APQP leader. Then the person like me, when we worked in foundry, when you are joining at OEM, then you can understand the real pain areas in foundries. And it is very easy to connect the problems at foundry and the expectations of OEMs, means the design aspects. Then it also takes very convincing and it's easy to make a win-win proposal when you are making any projects. I think whoever is working, it's very good for at least suppliers to get their proposals and try to implement at OEMs. I'm going through a few slides about my organization's mission, vision, and what we are working and what is our product and all these things. Then also I will talk about our casting commodity, what are the challenges and what we are expecting from our business partners. Atlas Copco Group, we have our customers more than 180 countries. 43,000 people, employees are working in Atlas Copco in almost 70 countries. We established in 1873. Maybe next year it is almost 150 years. From Stockholm, Sweden. And we have a turnover around 11 billion euro and with operating margin 21.2%. Then I would like to stop here to mention our purpose statement. Our industrial ideas empower our customers to grow and drive society forward. This is how we create better tomorrow. This means we continuously innovate new, smarter, and energy-efficient solutions. During that, we always interact with our customers to understand their needs. We ensure we fulfill their needs. Also, we do all these things with strong commitment and contributing the solutions which is going to sustain in long run, sustainability in long run. Our mission is first in mind, first in choice. Whenever the customer want to purchase a customer, he should first, the compressor come in his mind is Atlas Copco. And as I mentioned, our core values are interaction, innovations, commitment. We always think what our customer needs and how we can give a perfect solution to our customers. And our vision, sustainable, profitable growth, this we do in highly ethical manner. We all employee and our business partner, we sign a business code of practice, and we give number one priority for safety and well-being. And our all solutions, products are continuously innovated, and we have a most competent team to understand customer needs, to understand business partners' needs, to give a win-win proposals, win-win solutions, and we use our resources very efficiently. In worldwide, Atlas Copco business area is decentralized group, which is classified into a type of products. Mainly, I can say a compressor technique where all the compressors, different types of compressors like industrial air, oil-free, portable airs, such compressors are categorized into one business area. Then we are into a vacuum technique. We are into industrial techniques and power techniques. These four business area, our management, our group management is common, and we are classified into all these business areas. Our customers are in all industries. Our medical gas solutions gives a clean air as well as other gases in almost many hospitals. In USA, it is more than 50%. In hospitals, a clean air provision is done by Atlas Copco medical gas solutions. If you take an example of in tools, many almost aircraft manufacturing and car manufacturing, they rely on Atlas Copco tools and fastening solutions. Our vacuum pumps are used to simulate and test the highly demanding condition in space. Our small electric compressor with silent features and energy efficient, you might have seen on roads. These are all applications. One more important thing, our compressors are used to brew beer in all industrial produced beers in worldwide. Our core technology is in screw technology, oil-free screw technology, oil-injected screw technology, turbo technology, piston technology, and tooth technology, scroll technology. We have a compressor with all these technologies. And these are the innovative products and services which we offer to our end customers. And we are working with more than 50 worldwide brands present in market. Now I quickly go to the casting requirement which are required for manufacturing these compressors. Mainly we are purchasing FG260 grade cast iron and FG300 cast irons and AGN, ductile iron with different grades. And I'm talking about from Pune, Dapodi factory. We also have a Chakan factory wherein the casting range is varying from minimum 5 kg to 1200 kg. And we are dealing with a batch size of 5 and 10. We are not like an automobile industry, it is an engineering industry. And due to this batch size and the weight of casting, we have to stick with hand molding, heavy code jobs, and our annual turnover is also around 2,400 to 3,000 tons of castings. We have around 10 supplier base, 8 to 10 supplier base. Also, our suppliers, our business partners are supplying casting to us as well as exporting to Europe and China. Our future plan, here we can see there is a very good market conditions and there is a huge requirement. Considering what we are purchasing today, we can see there is always 8 to 10% growth on every year for local market as well as export market. Now we are thinking, we know what are the challenges our Indian industries are facing. and what are the new emerging technology. There are very few suppliers who are already working with emerging technology like lost form casting process, 3D sand printing process to work on a complex castings. These are the few pictures you can see. Those casting range weight is around 500, 700 kg. Those are already produced in with hand molding or omega mixers suitable for hand molding. Some of the crankcases, cylinders are very critical, which is having a water jacket, air jacket course. After machining, there is a hydro testing, pressure testing, and the casting results are visible at the end. Means after producing a casting, machining, if the casting is leak, then we have to throw the castings. And this is a major problem what we are facing in many cylinders. And last two pictures about the CNG compressor. This business from last 4-5 years, there is a huge market. We ourselves, our business increased CNG market from 5 compressor, it went to 25. Means almost 5 times we already increased. And we can see another 40-50% increase in market in next 1 or 2 years. There is a huge market for CNG compressors, cylinders, castings requirement. You can see where we are struggling with our business partner, with our suppliers due to criticality of the castings, the design, and when we are working with suppliers, we came to know that it's like impossible, it's very difficult, and all these things. But when we are thinking to solution mode, there are options, there are solutions. We also consider suppliers' proposals as well as the design requirement. The win-win situation we select and we are going ahead. These are the just few examples how criticality you just imagine. Now I am going to talk about what are the challenges we are facing, or maybe the suppliers who are already working with no-bake foundries, hand molding and omega mixers. Due to a small batch, the casting weight is more than 300, 700 kg. The end customer requirement is 0 ppm, lowest rejections, lowest losses after machining, and we are expecting very good surface finish. When you are working with a small batch size dependent on manual hand molding and manual core making, then achieving criticality, surface finish is a challenge. I can see that. Also the requirement is increasing for, we also purchase like a critical casting like a crankshaft, connecting rod. There are many non-destructive testing requirement. If we don't do, then we already come across, we face many field failures, the crankshaft failures. That's why these non-destructive testing on crankshafts or critical parts is very important. When we implement that, then we notice again rejections. Also, there is a new treatment called CED coatings, which is helping to overcome the issues in manual painting. This is replacing the KTL coating, or the CED coating is a very good when we increase the service life of our castings in field. When you want to export our parts to Europe or China, then there are requirements like PED requirements, CE, U stamp, ASME regulations. Many of our suppliers still has to work. They think, okay, if we go for this certification, there will be increase in cost. Then it is very difficult to absorb and get that market. But there are opportunities. What we think, looking at all this, when we interact with our business partners, we also convince their problems, their bottlenecks. But when we interact with our counterparts in Europe and China, our counterparts are already working on emerging technologies. And when we discuss with our Indian business partners, then we get the technology like a lost form casting process. I think this is one of the very good process which few Indian suppliers are already into that and they are working. But if you take an example, China is, there are many suppliers and I think they are doing better than Europe, what we can see that. And this lost form casting process is a very good solution for hand molding, because the major bottlenecks in hand molding processes are core making and petling. Whenever we interact with our suppliers, the most of the lead time, the most of the problems are laying out that they have a major manpower issue. Even though there are manpower doing petling work, it is a very critical. But these bottleneck operation can be de-bottleneck through lost form casting process. Those are hidden costs. Supplier has to work on those costs and to explore this technology. How this lost form casting technology is going to help a OEM? We already started working. OEMs are integrating two casting into one casting. By this way, the OEMs are reducing their cost. And the same expectation from our business partner is they're supposed to reduce cost on core making, petling, where they are already spending not only a direct cost, indirect cost also. If we business partner and customer, if they are both working on this technology, I think this is a very good future for business like for engineering industry where the castings are very critical and we have to work with small volume. Then second, one more technology wherein if you can see the pictures, we already worked in lost form casting. Also, we did some prototype in 3D sand printing wherein mold and cores are printed. Mainly this is good for whenever you want to do a prototype and validate that prototype. But apart from this technology is giving a solution to the casting which are in serial productions, which are very critical in making core making or very critical in removing pew sand or such things. For critical casting, if you are not able to change a design and still you are expecting the casting has to be produced in gray iron and AGN, I think these two processes these two technology, lost form casting and 3D sand printing are the options. Here, my request to all our business partners over here, you please explore this technology. Maybe right now you might be thinking this is a very costly process. If customer is providing it, then you people are going to explore. But you also think how this is going to help you to resolve your problems in core making or problems in petling area. These two are very critical and those are manual dependent. And this is mainly, I'm not talking about automobile industry who are already in high pressure molding line and green sand process, but there are many suppliers who are still progressing in hand molding, no-bake sand process, omega mixers, because there are many engineering industries. I think these two solutions which are going to help you to reduce your hidden cost as well as to upgrade your technology. This technology is for next 10 years, 15 years, I don't know, but the complexity of the casting will be there, and this technology, mainly this 3D sand printing process is going to help the OEM to do many design changes. This is going to avoid investment in tooling. This will be the very good technology whenever there are new designs are going to come and to implement or to penetrate those new product into market. It is going to save a lot of lead time while doing this prototype and qualification of the parts. We are already working with our few business partners, and I request you also think on that. Maybe cost is not the only problem, but if you start looking at those solutions, you will get few ideas, and maybe it is going to help you for your business in next 10, 15 years, whatever these things. Thank you for this. If there are any questions, I'm open for that.
Thank you very much, Mr. Chandrakant Bande. Any questions you have? There's a man waiting with the mic, cordless mic.
And there is a general perception that says that lost form casting is more expensive than other castings. My research data doesn't coordinate with that, because for me it is a simple logic. You are completely eliminating cores. You are completely reusing your sand. So how is that cost more? I will like your inputs because you are more experienced in this field. I'd like to share something.
Yeah, we are exploring this technology. Our counterparts in Europe, they are already into this from last 15, 20 years. When we started working with our local suppliers, we also felt it is costly. But when we started working on our hidden costs, like the time which we are spending in core making, fettling. Also, the opportunities wherein we can reduce casting weight, where there is a possibility of integration. We made a special projects, means we made a special design where we integrated two castings into one castings, and then it reduces our cost. Then with new cost, when we offered our suppliers, thereafter our supplier is also worked on his hidden cost. Then we decided win-win situation. It is a win-win situation. It is a cost saving for good cost for supplier as well as cost saving for me. Whenever OEM is working, he always think on, okay, if I am adding this, how much cost I am going to save, and whether there is a return on investment. We did this project. Maybe we took our help of our counterparts in Europe. They already did such similar projects we did, and it was helping to us. For OEM, it is very good to all the complex casting can be done in lost form with integrating two casting into one casting, reducing machining allowances, reducing weight of casting. That is giving benefit to customers, which we pass on to suppliers. Then it is win-win situation for suppliers to work on this technology.
Any more questions?
Can I ask something more, if it's okay? Let's say 3 years or 5 years down the line, how do you compare cost-wise lost form casting and sand molding?
I think lost form casting cost supposed to go down compared to your traditional sand molding, sand castings, maybe Novec or CO2. Only thing is our Indian suppliers are still, they have a fear in mind. If I am investing, my learning cost, whatever I have to spend, I will be in loss, or I have to invest in that. Unless and until you start working, investing, and going through this learning curve, you will not be perfect. Okay, you have to go through that, but at the end, this is most cost effective. It will be a lesser cost compared to a traditional sand casting process.
So we have done with this. Thank you very much, Mr. I request Mr. Sabu to honor our casting by Mr. Chandrakant Bande.